frequency and Bode diagrams response to voltage. So first I'm going to be talking just a little bit about the background of the system, kind of go on about some previous experiments we performed, kind of basically say where we started this round of experiments for. I'm going to be talking about a little bit about the theory of frequency response and the Bode diagram and all that. And then I'll actually show you some of our Bode diagrams and other results that we drew. And finally, I'm going to be comparing the results of the step responses and the Bode diagrams. So let's go ahead and start. This is the system we're doing. It's voltage, basically. Power comes from the motor into the generator, or comes from a computer input, goes into the motor and the generator to power some load lights, and the output is voltage. See, there's the format. And voltage is a little bit more interesting in a lot of results. It's not quite as linear. It does this nice little shape right here. And actually, the generator has basically a memory, which it remembers. If you run it on a higher frequency and or higher input level and then drop it down to a lower input level, it's going to be at a higher output level than if you just started at that lower input level. So if you're going to run it at, say, 100% input and then drop down to 50% input, your voltage would be higher than if you just started at 50%. So that's what this second part of the graph represents, the step down. And we basically broke this up. We were given an input range, our operating range of 10 to 70 volts, which was about 66 to 83% input. So this is the step down from 82% input to 80% right here. As you can see, it's focused in on where the actual step down occurs, dropping from 82% input to 80%. And it curves down gradually. It allows you to find your patterns about parameters. There you go. So from those results, we got the gain of the system. As you can see, it's a lot higher in the step ups as opposed to the step downs. There's pretty high error involved in a lot of them. You can see here in the lower range, it goes all the way up to uncertainty. And with the step down, there's a large uncertainty as well for the middle range. The dead time had a very big step up for the lower range as opposed to the middle and the upper range, which are quite small. And as well as the time constant. As you can see, the step up for the lower range is much higher than the other two sections. And there's a great deal of uncertainty there as well.
Is this the craziest thing you've ever seen? Okay, go ahead, go ahead.
For the frequency response, when you basically put an input of a sine wave, you're going to have a fluctuating input that resonates around a certain baseline. And that baseline here looks to be about 40%, or about 40%. And it's going to resonate at a certain frequency. And that input signal can be compared with the output, which in our case is voltage, to find some other parameters about the system. And then each of these points can be plotted at a different frequency. So starting at one set frequency and dropping down to lower and lower frequencies. It creates a nice plot compared with the aspect ratio and phase angle for the system. And then as you can see from this, you go from 180 degrees to where it intersects your graph, go up, and this gives you FD for the system, where the system tends to kind of level off and follow a more asymptotic response. That's where you can get your K. And where it intersects right here, this is your, you can find your KCU, as well as the order for the system.
This is yours, this is the same.
This is, so, that's just theory of how to throw that. As you can see, this is, I believe, for 80% input right here. It gives the input right here and the output right here, volts ranging from about 62, a little over 62 to about a little over 68 volts. So. And this is the Bode diagram for the lower values right here. This line was fitted to give the parameters of the system for the lower values, as well as K of 0.45 volts per percent, an FU of 15 hertz, average response to the frequency of 0.15. It's first order. The KC is 6.7% per volts. And if you focus on this area, it's kind of apparent that it's not quite the same curve as most of them, because if you're going to try to figure out K for the system, does it tend to be more asymptotic up here or down here, where all of these results are 0.3? So it doesn't quite follow the same pattern. And for the middle values, it's a little bit more steady. As you can see, it fits a little bit more nicely modeled, and has a little bit less uncertainty. But our K value right here is 2.5 volts per percent. The FU is 7.8 hertz. The average AR is 1.2, order is 0.34. The KCU is 0.83% per volts. Now for the larger values, it's, the system has less uncertainty. It's more consistency, I should say. As you can see, the model fits in even closer with the results. And gives you a K value of 2.1 volts per percent, an FU of 8.4 hertz. AR 1.5, first order again in the case of this 0.67% per volt. So with the parameters of to fit the curve right here, this is the theoretical curve right there, and to fit that, it was a function of the gain, the dead time, the time constant. And as you can see, it fluctuates from 0.45, goes up, has a tendency to go up throughout the range. It's a little bit higher. Dead time has a not quite the same pattern. It's a little bit different. And the time constant also has a strange pattern too. This is the response for the load values. For the Bode diagram, as you can see, they are very low values. But for the step up can get quite different results. Much higher, certain magnitudes higher. As well as the step down was more in line with the Bode results. So, for the medium values, the step up is a little bit higher. Not quite as much as for the lower values, but it's more consistent. And the step down is more in line with, again, the Bode results. With everything except for the time constant, which you can see the Bode results gave much lower results than step up or step down. And for the higher values, the Bode diagram right here gave more in line with the step up on this one. Step down is a little bit lower. The time, dead time was pretty consistent, but the time constant was much higher for the step up. So overall, these values can be used to try to find the personality of the system, which is very complex, very almost inconsistent, and personalities of the system differ greatly between the high, the medium, and the low. A whole lot. And finally, the step function yield values for the Bode plot were much different than the results for the frequency. Or for the Bode and the frequency were much different than the step up and step downs. Any questions?